Hello students, welcome to Royal Palace PU College Jamkhandi online classes. My name is Sanjay sir and I'll be teaching you biology. Today we will be studying about another topic of the chapter called as Organisms and Populations, and the topic name is growth models. This topic will be very short and this is very easy and contains very less information in it. Remember, we'll be going with respect to the NCERT syllabus and we'll be understanding what are all the facts that has been given in the NCERT textbook. So let us get started. So with respect to different microorganisms, different plants and different animals, their growth patterns depending upon the different resources available in the forest or in the ecosystem, the organisms are divided under two categories called as the growth models. Now these models gives us an idea how actually the organisms are behaving, how actually the organisms show their growth patterns with respect to different resource conditions. Depending upon this, we have got two types of growth models. Growth model number one, exponential growth model. Growth model number two, logistic growth model. These are the two growth models which has been given in our NCERT textbook, and we'll understand these growth models point by point. Right. The first one, that is the exponential growth model. This exponential growth model, it is also called as a geometric growth model. Now, what is this exponential growth model? When consider in the forest, there are resources. Resources in the sense you can consider it is with respect to food, it is with respect to shelter, and it is with respect to habitat, etc. etc. When the resources are unlimited in the sense the organisms whatever they want to eat, there is no stoppage of it. The organisms wherever they want to sleep, there is no stoppage of it. The organisms whatever they want to drink, there is no stoppage at all. Now this kind of theory will be coming only as an imaginary concept. I repeat, exponential growth model is that kind of a growth model wherein which the resources are unlimited, which is a basic concept which tells us that this kind of model or this kind of stage wherein which the resources are unlimited is an imaginary concept. Now, if you want to express the same kind of the exponential growth model in terms of an equation, we can be writing this one as dn by dt is equal to b minus d into n, wherein which d by dt is nothing but rate of change or the difference with respect to time, and n is the population size or population density. And in case of an exponential growth model, this particularity is directly proportional to the number of births minus number of deaths. We can write it as b minus d, wherein which b is called as number of births and d is called as number of deaths, and it is multiplied with the total number of organisms present at that situation. Let me repeat it again, that this equation can be given as dn by dt is equal to b minus d into n, wherein which b minus d is nothing but a difference between total number of births or birth rate minus total number of deaths or death rate into n is nothing but the population number, how many number of organisms are present in that particular ecosystem or an area. If we consider b minus d, it is nothing but a rate of an increase, a rate of natural increase in the population. Of course, the value of b should be more, and of course the value of d should be less. Otherwise we cannot go into any kind of imagination because equation does not holds good. Of course, in case of b minus d, the value of b should be more, wherein which b is considered as birth rate and d is considered as death rate. So let us Consider B minus D is equal to R. Then what will happen to the equation? Now the equation becomes dn by dt is equal to R into n, wherein which dn by dt is nothing but a rate of change of number of population size or a density with respect to time, and it is directly proportional or equals to the rate of natural increase, that is R, into the total number of organisms. I repeat, dn by dt gives you R into n. This is an expression for the exponential growth model, wherein which the organisms are repeatedly, continuously dividing themselves since the resources are unlimited. Once again, I am telling you that this kind of growth model is completely imaginary. In case of forest or in case of any ecosystem, this kind of ecosystem does not or never holds possibly correct. It is an imaginary concept. Right? So about this equation can also be written as nt is equal to n naught into e to the power rt, wherein which nt is equal to the total number of organisms at the time t is equal to t, that is at the final time, whereas n naught is nothing but the total number of organisms which are present in the beginning, that is t is equal to 0. R, as I mentioned, that it is nothing but the rate of natural increase, t is nothing but the time, and e is the exponential pattern. This equation is resulted when the above equation is multiplied by the natural logarithm on both the sides, that is LHS and RHS. I repeat that the exponential growth model can be represented as dn by dt is equal to R into n, or nt is equal to n naught into e to the power R into t. Or when we plot these things into the graph gives us a J-shaped curve. Remember students, in case of exponential growth, the graph gives us a J-shaped curve. Don't forget this. Now understand this diagram. In this diagram, it is a diagram which is given in case of NCERT textbook itself. Now go for the diagram A, wherein which it is a clear mentioning that in case of x-axis we are taking the time, and in case of y-axis we are taking the population density. And when we plot these two things, we are getting a curve, and that is a J-shaped. Observe the diagram a J-shaped curve. Let us enter into another topic called as the logistic growth. Logistic growth, it is an opposite explanation for an exponential growth model. That is, in case of exponential growth model, the resources were limitless. The resources were completely unlimited. In case of logistic growth, the resources are limited now. Okay, now this is a more realistic way wherein which we can say that the food varieties, the water varieties, the fluid varieties, habitat varieties, each and every matter here is limited. Now this makes sense actually. In case of an exponential growth, it wasn't giving any kind of sense. Now this makes some kind of sense. Here we have to understand one particular word called as carrying capacity or K. What is the meaning of carrying capacity? Let us understand, friends. Now each and every forest has got its own boundaries. Within that boundary, this forest has got its own limited resources. Now with respect to these resources, the forest tells all the organisms of that forest that these are my complete resources, and within these resources itself you have to use up all the contents, whatever that is required by you, and more than this I cannot supply. So within that boundary itself, within that concentration gradient itself, the forest occupies itself that this is my limit. The forest or the ecosystem says that this is my boundary. The forest or the ecosystem says that this is my capacity. And till this time, it may be 100 organisms, variety of, and it may be of 200 organisms, 300 organisms, or etc. etc. Depending upon the number of organisms, the forest will be having its own capacity. More than that, it is not possible for a forest to accompany some more organisms. It clearly indicates that the number of organisms should be less and the size of a forest should be more, and the provisions or the help or the capacity of the forest should be more, and that is represented by K, and the value of K should be more as comparing to the number of organisms. Now, when the total number of organisms are plotted against time, it gives us some kind of a graph, and with respect to graph, one kind of equation. Okay, now this equation is called as Verhulst-Perl logistic growth equation. Okay, so let us go into the equation now. It can be written as dn by dt is equal to r into n in the bracket k minus n by k, wherein which dn by dt is nothing but the rate of change of total number of organisms with respect to time, and this is completely dependent on r, the natural increase, n, the total number of organisms at that particular time, and after that a graph, a section of an equation called as k minus n by k tells us that I am the carrying capacity. Within this carrying capacity, how many number of organisms are there? And these number of organisms will be utilizing my own resources, which are limited in nature actually. Okay, so which can be easily represented as k minus n, that is the carrying capacity minus the total number of organisms utilizing those resources divided by the total carrying capacity. Now try to understand, this is a very easier equation. I repeat it again, dn by dt is equal to r into n in the bracket k minus n divided by k. It is nothing but the logistic growth equation. Okay, so this makes a practical sense. This is a real equation, this is a real model, this is a real concept wherein which it happens in all the ecosystems, in all the forests wherein which the resources are limited. And when you plot this kind of equation with respect to x-axis and y-axis, time versus population size or density, it gives us a S-shaped curve, that is sigmoid shape. Remember students, in case of exponential growth model, the shape was J. Now in case of logistic model, the shape is S. The exponential growth model is imaginary one and the logistic growth model is the real one. Once again, the same kind of figure from the NCERT textbook. Observe the diagram number B. The B diagram explains us that it is a S-shaped curve, and in this curve itself we can say that there is a boundary line called as the carrying capacity mentioned as K, and the equation very easily, very systematically they have represented, that is dn by dt is equal to Rn k minus n by k. It is a sigmoid shaped curve, more realistic one as compared to another one. We can get a question, what will happen when the number of organisms are equivalent to the carrying capacity? That is, what will happen when k is equal to n? Once again, you can very easily say that it is not at all possible when the number of organisms are equivalent to the carrying capacity of a forest or an ecosystem. If that happens, we can easily say that it gives a word called as asymptote. The word is asymptote. Asymptote means that all the resources are completely used up by these organisms, and there will be nothing left in the forest, which means that there is not at all another provision for the growth of another organisms or etc. After some time the forest will collapse, after some time the forest will die off. So in case or in the reality, k will never become n, or k will never be equivalent to n. If at all it happens, it becomes or it gives a shape called as asymptote shape. Remember this. Okay students, I hope you understood this particular topic of population growth model, wherein which I mentioned two models, and I hope you understood these things.